Hello, chemistry students. Today we're going to be talking a little bit more about acids and bases. There's a few acids that the state of North Carolina expects you to know. And so I'm just going to kind of go through these real quick. Over here, we have a list of some strong acids on the left side. And then on the right hand side here, we've got some weak acids. We'll talk in a few minutes about what makes an acid strong or weak. So these acids, we have HCl is called hydrochloric acid, hydroiodic acid, hydrobromic acid. Then this is called sulfuric acid, perchloric acid, and nitric acid. And I'll post a list of these in Google Classroom for you as well. Over on the right hand side are weak acids. We have hydrofluoric acid, acetic acid, which is also known as vinegar, carbonic acid, and phosphoric acid. And then when we move to bases, things are going to get a lot easier. So our strong bases are our group 1 hydroxides and strontium and barium hydroxide. So I'm going to let you see a periodic table real quick. So our group 1 hydroxides and strontium and barium hydroxide, that's going to be these guys right here, which kind of make, I don't know if you can kind of see this, it kind of makes a letter B on the periodic table. So essentially, if our strong bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, then we have rubidium hydroxide, cesium hydroxide, then we have strontium hydroxide, which is SrOH2 because group 2 has a positive 2 charge. And then we've got barium hydroxide. So those are our strong bases. Any other hydroxide would be considered a weak base. So, for instance, with aluminum over here, we have aluminum hydroxide. That would be a weak base. Or if we take copper right here, Cu, we had copper 2 hydroxide. That's also a weak base. This is a weak base and a weak base. But our strong bases are these. Now, you might be wondering, well, why I'm leaving out francium. Well, francium is radioactive with the half life measured in a fraction of a second. So we're just going to kind of ignore francium. I assume that francium hydroxide would be a strong base, but you're never going to encounter it. And then hydrogen up here, very special case. Um, Hydrogen hydroxide is also known as water, which, as you're going to see soon enough, is really kind of the fundamental basis of what makes things acids and bases. Because this should be a base, because if we go back to our presentation, bases are hydroxides, right? So our weak bases are all other hydroxides. Well, the thing about our acids you may notice is that all of our acids start with hydrogen. So acids start with hydrogen, bases make hydroxides. Water, which is hydrogen hydroxide, is simultaneously both an acid and a base, which is what makes water so unique. And it's equal parts acid and base. And so water is, by very definition, what we call neutral. There is one other weak base called ammonia, which is NH3, because NH3, if you put it into water, will react to form ammonium hydroxide. And if you take some ammonia, you add it to water, and you put a little bit of blue food coloring in it, then you call it Windex. That's what it is. What we're going to look at to kind of wrap up this little lesson for today is what's called the Arrhenius model of acids and bases. And this is developed by the Swedish scientist Svante Arrhenius. What he said is that acids contain hydrogen and they ionize. In other words, you put them in water and they break apart to form H pluses or H3O pluses. So if you put hydrochloric acid into water, it breaks apart to make H pluses and Cl minuses. Or if we include water in the picture, a lot of times we just leave water out because this first little reaction is a lot simpler to understand. What's really happening is the water is reacting with the hydrochloric acid to make H3O pluses and Cl minuses. So H3O plus and H plus, they're really just the same thing because H pluses, when they're in water, attach to the water and make an H3O plus. Then Arrhenius says that bases contain hydroxides. They ionize or break apart to make hydroxide ions. So if you put calcium hydroxide, which is a weak base, into water, it breaks apart to make calcium ions and two hydroxide ions. Now, a little bit of terminology. H3O plus is what we call hydronium. H plus is called a hydrogen ion, or it's called a proton, because if you remember, a hydrogen atom is just a proton and an electron. And if something has a positive charge, it's lost electrons. So all a hydrogen ion is really just an individual proton just floating around. If you put that hydrogen ion into water, it reacts to form hydronium. And then another term that you should know, this will come up in a bit, a salt is an ionic compound that's not an acid and it's not a base. It contains a metal, something on the left side of the periodic table, and a nonmetal or polyatomic ion. And it's something that doesn't start with hydrogen and it doesn't end with hydroxide. So, for instance, sodium chloride, calcium phosphate, um, copper 2 sulfate, all of those would be what we consider to be a salt. It's an ionic compound, but it's not an acid, it's not a base. The last thing that we're going to go into briefly is what makes an acid or a base strong versus weak. Because I showed you that list a little bit ago and I broke them up into strong versus weak. Well, a strong acid breaks apart completely in water. So when it ionizes, it splits apart 100%. So you have zero HBRs left in solution. It's 100% H pluses and Br minuses. Whereas a weak acid only partially does this. So carbonic acid, only maybe 1 or 2% of it will break apart into H pluses and HCO3 minuses. Now, for those of you who take more advanced chemistry classes in the future, we spend a month in AP chemistry really analyzing weak acids and weak bases and how they break apart and react. So if you're interested in how that works, we can quantify what this partial amount is. But we're not worried about that in this class. You just need to know strong acids, they break apart completely. Weak acids, they only break apart a little bit. They like to really stay together. And this just shows the reaction again if we add water into it. Now, bases is the same thing. Strong bases ionize 100% in water to form hydroxides, and weak bases only do it a little bit. So if you have potassium hydroxide, it breaks apart 100% into potassium ions and hydroxides, whereas a weak base, only a small amount. You're going to have like 99% of it as copper 2 hydroxide, and maybe 1% of it breaks apart. So that's the difference. Now, you may be wondering, is there a way to remember whether an acid is strong or weak? Well, this is not a comprehensive list of every acid that exists. For instance, I don't have oxalic acid or sulfurous acid or hydrosulfuric acid on here or any of those. But there are 6 strong acids. These are the only strong acids. Any other acid is a weak acid. So if you can just remember these 6 are the strong acids, then these are weak. And then for the bases, I showed you the little trick on the periodic table. And then if something doesn't start with hydrogen, doesn't end in hydroxide, it's a salt. So your little activity for today is I'm going to give you a list of some compounds, and you're going to identify whether it's a strong acid, strong base, weak base, or whether it's a salt. So every compound I'm going to give you falls into one of those categories. So good luck with that. Tomorrow we will delve into pH and its evil twin, POH. Good luck.